Bismillahirrahmanirrahim. I am like Adib from chemistry department, and today's topic of my presentation is basically a research topic, which is on drying of green chilies in direct sunlight and in a solar dryer. First of all, introduction. Chili plant is a small bush that grows up to 0.6 meter tall. It has a white flower which produce fruits of different sizes and shapes. Like other food, the preservation of chili is also a vital concern. Fresh chilies with their high water content are prone to decay. By removing moisture content, they become more resistant to spoilage and their shelf life is extended. The preservation of these allow to enjoy the heat and flavor of chilies year round, even during their non-harvested period. For preservation, the best method is drying of chilies. The climate at the time of harvested and the anticipated uses of chilies will influence the drying selection. The cheapest way available to sun drying is the preferred approach for using the dried chilies at home. But in reality, sun drying works best in arid regions with lots of sunshine. The drying process will take too long in humid locations and the chilies risk becoming bad during that period. Fresh chilies are kept by sun drying the fruits in thin layers on hot drying ground, concrete floor, house roof. This process does not allow for regulated drying, resulting in a generally low quality dried product. Drying is extremely slow, taking 7 to 15 days depending on the weather conditions. Dust, dirt, moisture, animals, birds, rodents, insects, and germs can all taint chilies. Under these conditions, losses can reach 40 to 60% of the overall quantity. If there is a lot of rain falling continuously while the product is drying, up to 70 to 80% of it will be damaged. Because sun drying depends on the weather, it usually does not produce high quality products because of seed loss and breakage. Research has been done on the uses of mechanical drying to shorten drying times or enhance the quality of chilies. It is best to use a sun dryer if one is available because it will speed up the drying process and produce dried chilies of superior quality. The use of artificial dryers is only feasible in situations where there is a steady demand for the dried chilies. Solar drying is a promising alternative for chilies is not applicable for chili drying because mechanical drying is mainly used in industrial countries and is not applicable to small farms in developing countries due to high investment and operating costs. Solar energy for crop drying is environmental friendly and economically viable in developing countries. The natural convection solar dried appears to have potential for adoption and application in the tropics and subtropics. Solar dryer. The procedure guided the design of a solar dryer for chili drying. The following factors were considered in the design of the natural convection solar dryer system: the amount of moisture to be extracted from a specific amount of wet chili, harvesting period during which drying is required, the daily sunshine hours for determining the overall drying time, the amount of air required for drying. Daily solar radiation is used to establish how much energy the dryer receives every day. Wind speed for calculating air wind dimensions. Construction of a solar dryer. The solar dryer was direct solar dryer type. It consists of a glass sheet, act as heat collector, drying chamber, and vent. First of all, collector area. The collector area was made for maximum utilization of solar energy. The floor of collector was covered with black cloth which act as black body and absorb maximum radiations for better drying results. The roof of collector chamber is covered with glass sheet which capture direct sunlight. Drying chamber. The drying chamber is made up of teak wood, which is an insulator of heat and electricity. It traps heat and does not allow to escape. The drying chamber dimensions are 3 by 2 width and 3 by 2 in length. Drying trays. Three drying trays are present which act as holders, and these are movable. These are also called holders or holding trays. These trays are made of lattice, use tiny holes, allow the passage of air which evaporates water content from chilies. Vent. For air ventilation, two vents are present. These act as inlet and outlet. Inlet for incoming air, and after passing air from chilies move outward through outlet. The inlet is present at base and the outlets opposite in direction present at top side. This opposite direction allow the air flow smoothly and increase evaporation rate. And in this diagram you can see how we design our solar dryer. It is basically made up of teak wood, and it contains four legs which support. These are the holding trays where we place our product, and in this diagram you can see we use a lattice sterile gas from which air is passed through the products and the water content is evaporated. And in this diagram you can see the top side of the solar dryer and the other sides, and you can easily see your product while drying, and you can easily record your temperature. And in this solar dryer we use thermometer which is a heat sensitive instrument to calculate or to determine the temperature inside the solar dryer. And you can also take pictures while drying your product inside it. Moisture content of chilies. The moisture content of agricultural product is calculated as a percentage of moisture based on wet weight or dry weight. Wet based moisture content is commonly employed in commercial applications. Dry basis is mostly utilized in research. MW is the wet base is equal to W minus D over W multiplied with 100, and MD is the dry basis is equal to W minus D over D multiplied with 100. The moisture content was determined using the oven drying method, which is a direct method. The product is weighed, dried, and then weighed. The moisture content was determined using the moisture content formula. Moisture to be removed from chilies. Water in the substance's exterior evaporates during drying, while water in the interior moves to the surface to evaporate. The porosity of the material and the amount of available surface area determine how easily this movement occurs. Low relative humidity, strong wind speed, and high temperature are other elements that may facilitate the rapid drying of food items. The following formula was used to determine how much moisture needed to be taken out of chilies. Mr equals MP into Mi minus Mf over 100 minus Mf. First of all, where MP is the sample weight in kilograms, Mr is the moisture to be removed, which is in percentages, Mi is the initial mass, which is also in percentages, and Mf is the final mass, which is also in percentage. Pre-drying treatment of chilies. Before drying our chilies, what measurements or what conditions or what we apply before drying our chilies? For the experiment, hand sorting was done to select chilies that were physically healthy, of uniform size, and had a great red hue. Water was used to wash the chili to get rid of dust and other debris. Hand labor was used to remove the large foreign materials. Next, the chili was distributed among the trays. An electric balance was used to weigh the chili before it was put in the dryer. Subsequently, the product was brought to the dryer for testing purposes. The experiment data was collected at 1 hour intervals between 6:30 am to 6:30 pm for 2 days. Almost 24 hours green chilies with 10 gram weight took to dry in sunlight, but in solar dryer the time period decreases. It takes 5 to 6 hours between 12 pm to 6 pm for 20 grams of chilies. Indirect sunlight. The sunlight of drying green chilies in presence of natural sunlight are given following. Keep in mind that during sunlight, more time is taken due to interruption of environmental factors. The time taken for drying is almost 24 to 26 hours for 10 grams of chilies before drying weight, and drying at about 41 to 44 degrees Celsius, and after drying the weight is about 2.4 grams, which shows that how much water is evaporated or how much moisture is removed from our green chilies. In solar dryer, the solar drying in solar dryer is not affected by environmental factors except the intensity of sunlight. The less humidity and increase in temperature is recorded. Temperature recorded by thermometer. The 20 grams of green chilies took 5 to 6 hours for drying at 53 to 56 degrees Celsius temperature, and after drying the weight loss is about 2.6 grams. Future advancements. The research shows that we can preserve foods and use these later. The drying method by using solar dryer is cheapest and environmental friendly. In this research, we show how we capture sunlight effect and increase drying rate. We use a solar dryer made up of teak wood, but if we use glass solar dryer, it would be more effective and increase the drying time within drying rate within shortened period of time. And this is only about of our research, and we learned that what is the temperature difference and how environmental factors influence if we dry our products in direct sunlight and in a solar dryer. And in the I hope you will get my point by listening or by viewing this presentation. Thank you.